Okay, guys, so today we will start our chapter number 4 of operating system course. And this chapter is a very long chapter, so we have divided this chapter into two parts, part A and part B. Part A is our lesson 4. So today we will start our lesson 4, and it's the part A for chapter number 4. So this particular chapter is basically about networking protocols and the basic services that we use in a network. So we have two main things to discuss in the chapter. Firstly, we will start with the network protocols, and specifically we will discuss two types of models here. We will discuss OSI model. I hope some of you guys might heard of OSI model. We will discuss OSI model. I'll just walk you through with all the layers of OSI model, and then we will discuss the TCP IP protocol, or you can say TCP IP model. A quick definition of Ethernet protocol and IP addresses. Like specifically, we will discuss IPv4, and I'll give you the classification of the IP addresses and basic stuff. So let's start with the first section, which is network protocol, where we will be discussing OSI model and TCP IP protocol. So first of all, network, as you know, network is basically connectivity of two or more computers. So let's say if you connect, let's say this is a network where you can connect two or more computers with each other. Okay. So network is basically connectivity of two or more computing devices. Okay. So for two reasons. Number one, so they can start sharing resources, for sharing of resources. Number two, for information exchange. So these are the two main reasons that why we create a network. A network can be of many type. You might heard of intranet, extranet, and internet, of course. And that's basically the typical three main types of network. There are many other types like metropolitan area network, personal area network, etc. But again, those are the subtypes of wide area network or local area network. So local area network is basically, let's say, for example, you have a small network at your home where you have a Wi-Fi router and plenty of devices are connected with internet and also connected with each other through this router, because there is a switch part inside the router, and this router gets you connected with ISP and eventually internet. Okay, so local area network is basically a network within a small building or location. So a network within a small geographic area. It could be within one building, it could be within home or stuff like that. That's called a local area network. While wide area network, it connects two or multiple local area networks. For example, a company might have 2 or 3 locations. Let's say one office might be located at Lawrenceville, second office might be located at Alpharetta. Let's say Gwinnett Tech, we have one campus here at Lawrenceville, second campus at Alpharetta. So these two networks, if you connect these two networks by using PSTN, public switch telephone network, it is called wide area network. Okay, where we don't have to lay down this fiber to connect these two networks. So we have connected these two networks, these two different locations using internet, public switch telephone network. Internet is basically like, if you connect all the wide area networks across the globe, it becomes internet. So internet is nothing, it's basically a network of interconnected computer networks. Network of interconnected computer networks is called internet. And in order to access internet, we use a service which is called which is a GUI of internet, and that is called web. So web provides interface. It provides interface through which one can access internet. Okay, like there's nothing saved on the website. In fact, the websites are basically stored on internet, on the servers. So all these physical components like wires, cables, servers, everything is called internet. while the web is just like a GUI. Okay, it's just an interface through which we can access internet. Next is the protocol. Protocol, it's basically set of rules for communication. I'm talking about the network protocol, of course. So set of rules for communication. If you are connected with a network, so what are the rules? Like what will be the size of packet, how you break down the data, like IP addressing, etc., etc. So set of rules for communication are mainly called protocols. So in networking, we use different type of protocol. We will discuss all of them. Let's start with the first model, OSI model. It stands for Open System Interconnection. So Open System Interconnection model, we use this particular model to describe all the computer functionalities. Like for example, regardless of what do you do, for example, if you are a security analyst, you might be working on one of the layer. So this is what we're going to discuss in OSI model. OSI model break down all your work, all your computer activities into different layers. There are 7 layers in OSI model. There are 7 main layers in OSI model. So all the computer functionalities are divided into 7 main frames or 7 main layers, in fact. So the highest layer is called application layer. This is the 7th layer, in fact. Then down to 7th layer, then we have the presentation layer. Presentation layer is 6th layer. Then 5th, 3, 2, 1. So the 5th layer is session layer. Transport layer is a very, very important layer in OSI model, and if you make a comparison of OSI model with TCP model, so that's the only layer which is present, which does the same thing here at OSI model, and it does the same thing on TCP model. We'll talk about it. Then we have the network layer, the layer 3. Then we have the data link layer, and the first layer, or you can say from top to bottom, it's physical layer. So these are the 7 main layers which are included in OSI model. Application layer, as name suggests, for example, if you are a software developer, so you are basically working on application layer. So application layer includes all the application through which user can interact with computers. So it provides a GUI, graphical user interface, or you can say it includes all the applications, through which user can interact with computers. So like your Microsoft Word, Microsoft Excel, browser, etc. All those applications through which you can communicate with computer are basically called application layer. Then we have presentation layer. On presentation layer, what we do encryption. So data encryption and data coding is performed on presentation layer. For example, cryptography, in fact, it's done on presentation layer. Then we have session layer. It maintains the communication session between the devices, between computers. Basically, on this layer, we issue the session token. So to understand what is a session token, let me give you an example. Let's say, for example, this is your computer, and for example, this is hotmail.com. Okay. So what will happen if you want to access your inbox? Firstly, you need to enter, or you need to forward your username and password. If you, after successful authentication, after verifying your username and password, what will happen? Hotmail will issue your computer for that particular session a ticket, or you can say a token. So what will happen from now onwards, whatever the communication will be, whenever you want to, let's say if you after opening your inbox, you want to see your calendar. Okay. So if you want to see your calendar, it's another application. You are asking for another web page. So, technically speaking, they should ask your username and password again, but they don't ask your username and password over and over. What happens? How they authenticate you? Through this ticket. So whenever you want to access a new service, new thing, it will be followed by the ticket, which is called the session ticket. Hackers, they steal this session ticket, and then they can actually hijack your session as well. Now the most important layer, which is called transport layer. Transport layer does plenty of things. Number one, a transport layer, it break the data into small packets. So we break down the data into small packets. Let's say you have 1,000 bits. So we cannot transmit all the 1,000 bits all together. What we do is we break down these 1,000 bits into a specific number of chunks, depending upon what data plan we have. So let's say 1,000 bits will be transmitted into, let's say, for example, 10 chunks, for example, 100 bits. So each chunk will be transmitted at a time. Okay, at transport layer, we break down the data into small packets. Other than that, we also assign the numbers as well. Let's say this packet is packet number 1, that could be packet number 2, 3, and 4. Reason is that because, I mean, since we are transmitting all these packets one by one, and each packet will be transmitted over wireless channel, so there is no guarantee that receiver will receive the packet in a sequence. Okay, there is no guarantee for that. So what will happen, there is a possibility receiver might receive packet number 1 first, then packet number 3, because packet number 2 might stuck over the network somewhere. Okay, so that is why we use ISN, initial sequence number, so receiver can reassemble the packets. Like for example, there is possibility packet 2 come after packet 3. So receiver knows that I need to rearrange them, to reassemble them in order to interpret the message. So transport layer is very, very important because break down the data, we assign port numbers, it defines services like which port needs to be open, close, and all that stuff in the case of internet. So transport layer, if you want to define it, it is responsible for establishing temporary communication between two applications, or you can say two services, in fact, and ensuring that the transmitted data can be reassembled in proper sequence. And in order to reassemble it, of course, in transport layer, we add the numbers of each packet, which is called ISN, initial sequence number. Okay. Network layer, let me write down here. Network layer is basically, on network layer, what we do, we implement the network, like logical implementation of network. If you are a network designer, so you probably be working on network layer. Logical implementation of network, what we do is we assign IP addresses. So assigning of IP addresses. So that's what we do on network layer. And then we have a data link layer. Data link layer, on data link layer, what we do, it uses, it's also called Ethernet layer as well. Some people, they call it Ethernet layer because Ethernet protocols run on this layer. On data link layer, it allows the devices to communicate with other devices connected on the same network. Connected on the same network. So if the devices which are connected with the same network, they want to communicate, they use data link layer. What does it mean? Let's say this is a small network within one building, local area network, and we have plenty of devices connected with each other. So let's say computer A wants to send a packet to computer B. So it will use data link layer, and how they can do that, they need to know, like computer A needs to know the MAC address of B. If you know the MAC address of B, then you can directly communicate with B. If you don't know, you cannot do that. Okay, and this is what we do in Ethernet layer. On Ethernet layer, we run a protocol called ARP protocol, Address Resolution Protocol, which provides the MAC addresses of nearby devices. It resolves basically the IP address into MAC address. We will discuss ARP protocol in part B. Now the last layer is the physical layer. Physical layer, And the physical layer, the first layer, in fact, from bottom, physical layer is basically it does analog, it converts analog signal into digital and digital back into analog. What does it mean? Let's say you are basically getting internet signal from ISP and it travels all the way through the coaxial cable or, for example, optical fiber. Please remember, whenever the signal is traveling through the channel, it is traveling in the analogous form, which is called electromagnetic waves. So when it gets to your computer or your router, no, the problem is that your computer only understands digital language like 1010 and all. So we use a device called Modem, Modulator and Demodulator. So modulator part, it converts analog, because this analog signal is coming from here, into digital, so computer can understand that. Now if you want to send something out of your computer, again you have a digital data to send. So again, modem is in between. So demodulator portion, it converts the analog signal, digital signal into analog, so it should be compatible with the wires. So this is what we do on the physical layer. So these are the 7 layers of the OSI model and their functionalities. Now let's move on to the TCP IP protocol. So first of all, the TCP IP protocol, or transmission control internet protocol, it's basically it is the protocol that is required for internet communication. Or you can say, if a devices they want to communicate over internet, they need to use this protocol. Allows the devices to communicate over internet. So devices, they cannot communicate over internet without doing compliance with TCP IP protocol. Okay, so again, just like TCP IP layer, OSI model, we have a few layers here, but unlike the TCP IP layer, we have here 4 layers. So basically, we does typically the same stuff that what we were doing in OSI model, but we have compressed the layers. Like transport layer is basically doing plenty of tasks. The transport layer, it does exactly the same stuff that OSI model does. So basically, OSI layer 4, which is transport layer, and TCP IP transport layer does the same thing. The same thing. Okay. Now let's start understanding here what we do on these layers. What are the different protocols that run on these layers? First is the application layer. As the name suggests, application layer, all the computer application through which user can interact with computer and eventually with internet, basically run on application layer, like your Microsoft, your browsers, like your multiple protocols on the browser which supports browser, like HTTP. You can download something, FTP, SMTP, simple mail transfer protocol, etc. All these protocols run on application layer. Transport layer, when the data gets to transport layer, we break down the data into small packets. Other than that, what we do, we add the port numbers, like it defines through which port the data will go out depending upon the service. Internet layer, we add the IP addresses, okay, source and destination. And then we have network layer, where we use the MAC addresses of source and destination. So let me just construct a TCP packet so it will make more sense to you guys. So let's say, for example, you just open your browser. You just have opened your Google Chrome or whatever your favorite browser is. You have opened it up and you just type here www.gtc or gwinnettech.com or .edu, for example, .edu. What will happen? So once you open your browser, what happens? You have created a HTTP header. Since you just want to visit this website, so HTTP header will be created. Like header means like if you go to your view the developer's detail or view message source, you will see the HTTP header. You will see the communication. Now what will happen? You just want to actually visit this website. So you open your browser, so HTTP header will be created, which is request to the web server, please send me the website. When this packet will get to the transport layer, over the transport layer, now what will happen? Data will be broken down into small pieces, but other than that, like you will have the same HTTP header here. But when it gets to the transport layer, again, the data or your packet didn't didn't go through. As of today, it is within your computer, within your browser. So you just type it within your browser, it will go to transport layer. Over the transport layer, it will add TCP header. And what is TCP header? TCP header will add the source and destination port numbers. Source and destination port number, like through which particular port this packet will go out, and on the destination through which port it can get into their computer. So let's say if it is the HTTP, so port number 80, of course, will be added here. When this packet get to internet layer, now another chunk will be added here. So now you have HTTP header again right here. You have TCP header right here. IP header will be added. And what is IP header? It is nothing. It is just the IP address of source and IP address of destination, like your computer IP address and the destination IP address, which is gunnettech.edu. Okay. And again, all the routing protocols, they also run on internet layer, like routing information protocol, open shortest path first, etc. Next is the network layer. When it gets to the network layer, then another packet will be added, and that particular packet is called Ethernet header. And this Ethernet header, what is that? This Ethernet header, again, we have IP here, TCP here, HTTP here. So Ethernet header, it basically adds the MAC address of source and MAC address of destination. Please remember here, and that's very, very important. Destination MAC address doesn't mean that the MAC address of gunnettech.edu. Destination MAC address will be MAC address of your router, your gateway. Let me explain you. For example, this is your computer and you want to access, for example, gtc.edu, this website. It is outside your network. So what will happen? You did everything here. It has an IP address. You also have an IP address, everything until internet layer is fine. Now what will happen? Your packet, you will transmit the packet, but the destination MAC address will be the MAC address of your router, not the MAC address of this. Please remember that. Once the packet gets here, gets to the router, in the router will open the packet and see where you want to route this packet. What's the destination through the IP address? Then router will actually use the routing protocol and find the best path for you. Then router will add the MAC address, again, reassemble the packet and put the MAC address of the router, which is next to gtc.edu. So the MAC address will get changed. So this MAC address will get changed when the router gets to the next hop count. And that's what we discovered through the trace route, in fact. Okay. Over the application layer, there are plenty of protocols that are basically running. For example, HTTP, I believe everybody's well familiar with that. Then we have HTTPS secure socket layer, the technology, port number 44380. FTP file transfer protocol, it allows you to download and upload something. So let's say it allows the clients to download and upload. So if you want to download or upload something on the server, we use FTP protocol, and it's a secure one again. Other than that, SMTP, simple mail transfer protocol, it is also run. It defines the formatting and controls the flow of email over the internet. Then we have DHCP, dynamic host configuration protocol, like the automatically signing of the configurations. DNS, domain name service. These are some protocols which run over application layer, like what you can do with your browser. There are many other, like POP3, IMAP. These are the protocol. We will discuss those protocol in over part B, in fact. What else you need to know? Okay, so I think again, one thing which is very important. Please remember, let's say this is your network. Let's say, for example, this is a small network. So you have this router which connects you with ISP and eventually internet, and you can access Amazon.com, you can access Chase Bank, you can access, for example, Walmart website, everything over the internet. Now the thing is, let's say if you are connected, let's say this is a network. So over on your network, for example, let's say if your gateway is not configured, gateway means your router is basically your gateway. If your gateway is not configured properly, so if gateway is not configured properly, then what will happen? You can communicate with local area network devices. Then local area network communication will be fine. But you cannot communicate with remote computers. But you cannot communicate with remote computer, like the computers outside your local area networks. Okay, that's very important, and you need to remember it. Okay, so let's move on. Then the communication protocols. Protocols can be unicasting. Unicasting mean, for example, let's say we have a device called switch. When switch receives a packet, switch can control over it whether send the packet to all or because switch knows the MAC addresses. So when you send the packet, switch can control over it. Let's say this package is for this, so switch can forward the packet to only that. So switch is basically unicasting. Unicast mean one-to-one, so you can do one-to-one communication as well. Then switch can be multicasting. Let's say that the sender wants to send the packet to these two computers, so switch can do that one-to-many. Broadcasting mean if you receive the packet, switch can do that, but there is another device which is called hub. It is basically one-to-all. One-to-all, that's basically broadcasting if you send the packet. A packet can be of two types, TCP packet or it could be UDP packet. Over internet, there are only two types of packet. A packet can be TCP or it could be UDP. TCP mean connection oriented, while UDP packet is called connectionless. Connection oriented mean, for example, let's say you want to visit a website. Firstly, your system will make a connection, like this is your computer. You want to access this website. First of all, we will send a packet and ask them, hey, are you listening to me or not? We establish a three-way handshaking. So it's called sync protocol. So firstly, we'll send a packet before we run this, the protocol and all that stuff. We ask them, are you listening to me? If they respond you back yes, then we will say, okay, I'm going to send you the packet. This is three-way handshaking. In UDP, regardless of whether they're listening to you or not, we actually send the packet, like ping packet. So if you open your command prompt, just type ping space www.gonetech.edu, what will happen? I mean, they might have did some security rules and they not respond to your ping packets, okay? So, but again, the thing is, regardless of whether the website is up or not, you will send the 4 packets, in fact. So let's move to the second part of section 2 of chapter number 4, Ethernet protocol. As I mentioned earlier, Ethernet protocols, they control the local area network communication. And Ethernet protocol mainly relies on 2 layers. So 2 sub-layers run on Ethernet layer. 2 sub-layers are included. One of the layer is called LLC, second is called MAC. LLC is basically logical link layer, and it is the media access control. So to communicate with the local area network devices, we need to know the MAC address of the devices. Please remember that. If you want to communicate with any device, so we need to know the MAC address of that particular device in the local area network. For local area network, it is very important to know the MAC address. How we can get it? If you open your command prompt, just type ARP space -a, you will see your ARP cache. We'll discuss ARP in detail. Next is the LLC, logically, it's just an interface between the physical layer and the network layer. Network layer interface. It connects the network layer with physical layer. Okay, that's just the connectivity. Next, the IPv4, the IP addresses. So a typical IP address, it has mainly 4 parts. If you see a IP address is separated like with the dots, and you should see 4 main parts here. The first part, it defines the class of IP address, and typically each part is made up of 8 bits. 8 bits. So total, the IP address v4 is of 32 bits. So IPv4 address is of 32 bits, and each part is of 8 bits, made up of 8 bits. Let 8-bit mean IP address could be something like, if I convert it into binary. So let's say we might have 10.0.0.1. For example, this is your IP address. If computer doesn't understand that because it's in decimal, how computer interpret it, since each part is of 8-bit, so we need to convert the calculate the binary for 10. So as you know, the binary 1, 2, 4, 8, 16, 32, 6, 64, 128. That's 8-bit. So in order to calculate 10, so if we 1 here, 8 plus 2, 10, and everything else will be 0. So what will be the binary for that, or what will be the 8 bits? It will be 4 zeros, 1, 2, 3, 4 zeros, 1 0, 1 0, dot 8 zeros, dot 8 zeros, and then all the way 7 zeros and 1. That will be the binary for the one. I believe you guys know that how to do this, and the conversion decimal to binary and all. Now the thing is, the first, as I mentioned here, the first part of the IP address, it defines the class of IP address. For example, class A. If class A, which we use for largest network, we can generate 16 million different IP addresses if you do the subnetting by using class A. So class A is basically, if you differentiate, like this is from the class A. It starts from 0 to 127. It means if the starting point is 0 to 127 somewhere, it means that IP address is from class A. Then we have class B. Class B IP address start from 128 to 191. If the first part is 128, 129, 130, so it will be class B. Class C IP address is 192 to 225. And then we have class D and E as well afterwards. But in the smaller network, like where we can create maximum 256 assigned different IP addresses, it's class C. Here we can generate thousands of IP addresses in class B, and it's for the like smaller, like medium-sized networks, and in the class A, the corporate or the biggest organization where they have devices in millions, they use class A. Because here, for example, in the class A, what happens? The first part is fixed. You cannot change that. Let's say it is 10, it will never get changed. You cannot manipulate with that because this is called your network address. You can change these IP address, these particular parts in order to generate new IP address. Let's say you can make all zeros, or you can make it, let's say you can put 1 here, all zeros here. Yeah, you can make it 2 here, all zeros, something like that. You can manipulate with IP addresses here to generate new IP addresses because first part is fixed. In class B, the first 2 parts are fixed, which are your network identifier, and you have spaces for that. Class C is basically the first 3 are reserved for network identifier. You cannot change them. Only thing that you can change is the last part. Okay, so subnetting, I believe everybody's well familiar with subnetting. If you took any networking course, it is to reduce the size of a network. And your local IP address, for example, if you want to see what is stored in the local address, the local host IP address is 127.0.0.1. This is reserved for local host. Okay. Gateway, as I mentioned earlier, and I explained you guys, to connect with internet, you need to know you need to be configured with gateway. Gateway is basically your router IP address, or your router. That is your default gateway. And IP address of router is basically default gateway. It should be configured correctly if you want to communicate over internet. So that's it about our chapter 4 part A. We will continue this in our part B.